Syndeia, the model-based engineering solution from Intercax, creates, manages, and uses connections between engineering software tools, including PLM, CAD, ALM, simulation, requirements, and project management. It uses a system architecture model in SysML as a central hub, clearinghouse, and high-level roadmap of the system. As our system models have grown in size and scope, we need new ways to visualize them. We want to be able to see at a glance what tools and what kinds of models have been connected. We want to be able to search that network for specific kinds of elements and specific kinds of connections. Most importantly, we want to be able to trace connections from a particular element across the network, identifying what affects our starting point and what our starting point affects. In Syndeia 3.0, released July 2016, we introduced new interactive visualizations to support these use cases. A chord plot provides global visualization, a snapshot of what tools are connected and how densely. The statistics on the right for a power plant model show 172 elements engaged in 111 connections. The circles on the boundary represent elements in different tools: SysML, Jira, GitHub, Simulink, Doors-NG, and Windchill. Each line or chord represents a Syndeia connection between tools. As we drag the cursor across the circle, each node and chord is highlighted and identified. The search term control identifies elements with that word in the element name. And we can filter the nodes by tool, by connection type, or by artifact type. Once the big picture is understood, we can focus on specific elements. But now a new factor must be considered. Our chord plot shows only connections between different tools, inter-model connections. But our system model also contains connections between model elements within a single tool, intra-model connections. To trace connections across the system model, we must be able to see both. Syndeia 3.0 offers two choices here. If we launch the auto layout graph from a single element in the SysML model, for example, the plant control and safety software block, that origin block, shown with a red border, is linked to other SysML elements, plus a Windchill PLM part, a Simulink block, and 2 GitHub files. The SysML activity allocated to the original block is further linked to a Jira issue, and the original block satisfies a requirement linked to a master copy in Doors-NG. Note that the connections inside SysML, both dependencies and composition, are directional, while the intermodel connections managed by Syndeia are not. In our graph, we could select for incoming, outgoing, and/or non-directional. In an alternative visualization, a tree layout, only outgoing and non-directional connections appear. But the left-to-right tree structure makes it simpler to follow a particular chain. Again, we follow a sequence from control and safety subsystem through to GitHub files and Doors-NG requirements via multiple connections, both inside and outside the SysML model. Syndeia 3.0 represents only the first steps in visualization for model-based engineering. We will be adding new plotting formats, and we will be adding the ability to view connections inside other tools like Doors-NG, Teamcenter, or Jira, as well as non-Syndeia intermodel connections. Most excitingly, we will combine visualization with powerful and user-friendly query capabilities to identify multi-segment linkages across the system graph. As always, innovations at Intercax are driven by customer use cases, so contact us to share your requirements and learn more about the future of model-based engineering.